Hi there, and welcome to 272analytics.com's tutorial on how to carry out a bivariate regression, linear regression, in R. A couple of caveats before we begin. I'm not going to be touching upon assumptions testing or post-estimation commands here. Those are slightly more complicated topics, and they have been covered elsewhere on the 272analytics.com statistical guide area. So I do suggest that you go to the more advanced R procedures if you're interested. Here we're just going to be looking at a simple regression of one independent variable on another, and we'll be doing so in the R interface. What I like to do is I start by pushing Control L and just going to a clear screen, which just looks, I think, better and creates less distraction. We'll be working with the cars database that's already in R, so you can just type in cars and push enter, and you'll see that we have a 50 observation data set with a speed value and a distance value. We don't really know contextually what these variables represent, and that's not really important for our purposes. We're just going to demonstrate what happens when we run a regression. So the code for regression in R, I'm going to post it here. It's LM, and over here you put in your dependent variable. There's a tilde, and then there's your independent variable. And in the advanced model, you're going to see how to add on more than one predictor. It's very simple, you just use a plus sign. But for now, since we just have one independent variable, we've entered it here, we've put a comma, and we've specified where the data are coming from, and then we just push enter. Now notice that with R, there are a couple of things that are distinct from other software programs. The first thing is you've created a kind of an object here, I guess you could call it, and you've entitled it reg or reg over here. When you create this code and you push enter, it doesn't really show you what happens. You have to use follow-up commands like summary here to actually see what the model results are. And this time you can actually see what's going on. You see that with every 1 unit increase in speed, distance goes up by just about 4 units over here. Looking at the readout, you see that both the intercept and the speed coefficient are statistically significant. You have standard errors and t-values, and that pretty much is all you need to look at. You can quickly look at the R squared here and see that speed variation predicts about 65% of variation in distance. One more thing that you might want to do here is create a scatter plot. I'm going to type in the code so you can see what I've done here. It's the scatter smooth command, and it's basically it's just this code. Instead of reading it over, I'll let you have a look at it, and you just push enter. And a couple of things to look at. The information here between parentheses is your title, so you could really have entitled it anything that you wanted. And you have your X and Y variables here, which you could switch out if you wanted them to be on different axes. And here we see that there's a positive relationship between car speed and car distance. And that's the same thing we saw over here. We saw that for every 1 unit increase in speed, there's about a 4 unit increase in distance. And that's what's being represented here with the line of best fit. Anyway, I hope this regression tutorial was useful for you. I do encourage you to check in on 272analytics.com for the more advanced version of the regression models in R. We also have a bunch of other tutorials in SPSS, R, Stata, and other software programs. Finally, I do recommend that you check in with us for consulting services for your Chapter 3, Chapter 4 needs, any kind of quantitative modeling, data analysis. We're the experts and we'd be happy to help you. Thank you.